All right, students. So it seems like some of these continuous probability density functions are a little bit trickier. So I was going to do problem 17 from the chapter review. And so if we've got a probability density function, that means that the integral over the whole region has to equal 1. So let's write that thing down and see what we can do. There we go. This has to equal 1. And so we can take the k and just sort of factor it out. And I can distribute the x squared to have 10x squared minus x cubed dx. So that's going to be k times 10x cubed over 3 minus x to the fourth over 4. Forgot to write my bounds of integration from 0 to 1. When I plug in 1, it's all going to disappear, so I just have 10 thirds minus 1 fourth. And let's see, what is 10 thirds minus a fourth? That would be 40 minus 3 twelfths times k equals 1. So k times 37 twelfths equals 1. In other words, k equals 12 over 37. There we go. We were already given that, so we knew that was going to be the answer. So I can clear the screen and just use that as we go through. Now, the expectation, the expected value, you get that by integrating over the entire region. We can still pull the k out and multiplying x times your probability density function. So just distributing that out, we get 10x to the third minus x to the fourth dx. So that becomes 10x to the fourth over 4 minus x to the fifth over 5 from 0 to 1. So that's going to be k times 10 over 4 minus 1 fifth, which I guess we could knock this down to 5 over 2. So making this into 23, all right, well, I guess 25 minus 2 over 10 times k. So we get k times 23 tenths, I guess, is the expected value. So let's substitute in 12 over 37. 12 over 37 times 23 over 10. Make this 6, make this 5. So I don't see this coming out to be anything pretty. So whatever that comes out to be, you can calculate it out with as a decimal or leave it as a fraction. I guess we'll need it again for finding the variance. So I guess I won't give up here. I'll actually calculate it. 6 times 23, what is that? 120, 138. So this will be our mu value. So we'll have 138. And then 5 times 37, what is that? 150 plus 35, 185. There's always a chance I screwed up my fractions there, but that looks good enough for now. Variance of x is usually easier, I have found, to do with this formula, the expectation of x squared minus mu squared. And so let's calculate the expectation of x squared. So that's going to be 0 to 1 of x squared times f of x dx. So again, we will factor the k out. We'll distribute the x squared. So then we have 10x to the fourth minus x to the fifth dx becomes 10x to the fifth over 5 minus x to the sixth over 6 from 0 to 1. Knock that down to a 2. And that's all times by k. So we have k times 2 minus 1 sixth. That's 12 sixths. So that's 11 sixths. So k times 11 sixths. And let's actually substitute k is 12 over 37. It's 11 over 6. So we get 22 over 37. So Our variance then is this number minus this number squared. So I would just type this into a calculator. 22 over 37 minus 138 over 185 squared. What does that come out to be? It's not particularly interesting what it comes out to be, but that's okay. 0.04, 0.0382. Great. Okay, so for what it's worth, there it is. Last one, finding the median value. The median is just where 50% lie below and also 50% lie above. And so there's actually two ways you could do it. You could say that the median is the m value where we go from 0 to m of f of x dx, and that gives us 0.5. But that should also be equal to going from m to 1 of f of x dx. So it sort of depends on which one is easier. I would suggest this one because plugging in 0 is usually pretty nice. So we'll use the left side. Okay, so we've already looked at this several times, so we know it's going to be k times the integral from 0 to m of 10x squared minus x cubed dx. So k times 10x cubed over 3 minus x to the fourth over 4 from 0 to 1. So that's k times 10 thirds minus 1 fourth. No, sorry, from 0 to m, excuse me. Let's fix that. I went a little fast there. So m to the fourth, 10m cubed over 3. Does that look right? Yeah. And so then we see k times 40m to the third, I'm finding a common denominator, minus 3m to the 4 over 12. And this is going to equal 0.5. Let's see. So 12 is equal, k is equal to 12 over 37, right? So I can cancel out the 37s, and then I can say multiply by 37 to get rid of the fraction. So what is 37 times 0.5? Would that be 18.5? So I've got 40m cubed minus 3m the fourth equals 18.5. This is looking like something that maybe you would want to solve on your calculator. You just actually you can graph it. I'm wondering, is there something easy I'm missing here? If I set it equal to 0, I don't think so. Usually when there's a quartic uh, it's a quartic equation like this, it's pretty nasty. Especially because we know we're going to find an m value between 0 and 1. So just use your graphing calculator. I guess let me pause and grab one and I'll show you. All right, now I got my graphing calculator. So it looks like I could do in the y equals, I can do 40x to the third minus 3x to the fourth. And on the other side, I'll do 18.5. So I'm just typing that into the y equals, hitting graph. My graph is all messed up. So I'm just going to zoom 6. Okay. I got to make sure that I can actually see the window. So I got to go up to change my y bound. Okay. So here's what I'm seeing. I want to find the intersection. So I hit the second calculate button, intersect number 5. First curve, second curve, guess. And it says m is 0.789. Wow, I wrote that in the wrong spot. 0.789. So you could verify, if you wanted to, that when you type in the original probability density function, where you have 12 over 37 times x squared times 10 minus x, that if you graph that original probability density function right there, that when you do the integral, second calc integral from 0 to 0.789, that it comes out to be a half. And if you look down there in the blue, it's pretty darn close to a half because I rounded it off. So there you go. Please ask questions if you got them.